Okay, today we're going to do the Unit 5 practice test. So for number 1, you can actually go ahead and plug this into Desmos. So go ahead and go to your wrench and turn on complex mode. So we are going to type in exactly what they're giving us, 7 minus 4i to the third power. And it will simplify it for us. Now this is not going to work when we have division, but for this problem, we can go ahead and do it. So your final answer is just be 7 minus 524i. Now for number 2, remember we can only simplify if we have like radicals. So we need root 5 and this to match. So let's go ahead and try simplifying root 125 and see if we can go ahead and get it to match. So 125, we can split into 25 and 5, 5 and 5, and we are going to get 5 root 5. So now we can go ahead and rewrite what we have. So 5 root 5 minus 3, and we're replacing root 125 with 5 root 5. So now we're going to get 5 root 5 minus 15 root 5. And of course, we're just going to treat these like terms, so we'll subtract the coefficients, and we're going to get negative 10 root 5 as our final answer. The next one, this is going to have to be imaginary, so let's just start off by acknowledging we have to pull out the I, and now we can change it back to regular root 40. We can go ahead and simplify 40 into 4 and 10, 2 and 2, 2 and 5. So we end up with 2 root 10. But of course, since we have the I out front, we just have to make sure that we remember to put it back. So 2i root 10 would be root 40, or I'm sorry, the square root of negative 40 simplified. Number 4, you could do in the calculator and just type it in, or you can go ahead and combine like terms. I know that 15i minus 15i is going to give me a 0 pair. And I know it's going to be 17 plus, and I know I squared is really just negative 1. So it's going to be 7 and then a minus 10, which will give me 7. For number 5, you could go ahead and distribute this. Distribute. We can find our answer that way, or we can go ahead and type it into Desmos. So let's try that. So 3 minus 4i, and then negative 7 minus 7i, and that will give us, let me double check this. Oh, plus 7i, I typed that wrong. And that is going to go ahead and give us 7 plus 49i. Okay. Now remember, when we're dividing, we can't plug the whole thing into the calculator. We can only use the calculator as a tool to help us do our steps. So if we know that we can't have an imaginary number in the denominator, so we have to go ahead and multiply by the conjugate. And of course, whatever you do on bottom, you got to do on top. And now we can go ahead and use the calculator to help us simplify the numerator and the denominator. So we're going to have 6i times 6 minus 9i. So in the numerator, we're going to get 54 plus 36i. And in the denominator, we are going to get 6 plus 9i, 117. And we could divide everything by 3, I believe. So let's go ahead and try that. 54 divided by 3 gives us 18. So let me divide by 3. Divide by 3. So that's going to give us 18 plus 12i all over 117 divided by 3 would give us 39. We can actually divide these by 3 again. And we're going to get 6 plus 4i all over 13. That's our final answer. Okay. Number 7, I'm going to go ahead and plug it into Desmos and see if I get an x-intercept. Instead of equals 0, I am going to do equals y though, so I can actually see the full graph. Okay. There are no x-intercepts, which means I am going to get an imaginary solution. So this one will have to use quadratic formula. So it's already set equal to 0, so I can say that a is 10, b is -4, and c is 10. So you know that x is equal to opposite b plus or minus the square roots of b squared minus 4ac all over 2a. Now I'm going to go ahead and plug my discriminants into Desmos. So -4, making sure I'm using my parentheses. 4 squared minus 4 times 10 times 10. We're going to get -384. We're going to get x is equal to 4 plus or minus the square root of -384 all over 20, which I really know is 4 plus or minus I root 384 all over 20. Let's go ahead and see if we can simplify the square root right here. So I'm going to come off to the side over here. 384 will break down into 96 and 4. 4 breaks down to 2 and 2. 96 will break down to 6 and 16. 3 and 2. 4 and 4, which both break down to 2 and 2. So I know I can simplify to, let's see, my square root. I got a 2, and another one, and another one, and now I'm left with a 3 times 2. So it's going to be 8 root 6. Okay, so let's go ahead back over to our problem and keep going. So we're going to get 4 plus or minus, and now that's going to be 8i root 6 instead of root 384 over 20. Now I can go ahead and I can divide the 4, the 8, and the 20 all by 4. So I'm going to do that, and then we're all done. And please remember that these are two solutions. The first one would be 1 plus 2i root 6 over 5. The second would be 1 minus 2i root 6 over 5. Okay. So number 8 says to find the roots. Let's go ahead and try graphing that first. X squared minus 6x plus 12 equals y. And no. Okay. So for finding the roots, we're finding the x-intercepts, which is when y is 0. Or the x-intercepts, which is when y is 0. So that's already set equal to 0, so we know that a is 1, b is -6, and c is 12. So we're going to get that x is equal to opposite b plus or minus, put my fraction bar, the square roots of b squared minus 4ac all over 2 times a. So we're going to get 6 plus or minus the square root of, let's see, -6 squared minus 4 times 1 times 12, which is negative 12. So I know that that's really just going to be 6 plus or minus I root 12 over 2. Let's try simplifying root 12. So 12 will break down to 3 and 4, 2 and 2. So we end up with 2 root 3. So we're going to get 6 plus or minus 2, don't forget the I, root 3, all over 2. And we know that we can divide 6, 2, and 2 all by 2. So let's do that, and we'll be all done. We're going to get 3 plus or minus I root 3 over 1, and we don't need to put over 1. So these are your two solutions. All right. Number 9 says a company wants to design a rectangular garden with an area of at least 300 square meters, but no more than 700 square meters. Okay, so we know that the area needs to be sandwiched between 300 and 700. The length is 3 meters longer than the width. So the length is the width plus 3. Provide 5 possible length/width combinations for the garden. So we have 2 ways to do this. You could definitely guess and check for this one. I'm going to show you how to do that in a second. But we also know that the area would just be the length times the width. And we already know that the length is just the width plus 3 times the width. So if you're going to solve an inequality, it would look like this. 300 is less than or equal to W plus 3 times W, the area, is less than 700. And we can go ahead and solve for our W interval and then go ahead and fill in some of those. Now to guess and check it, we could say, okay, let's say for funsies that the width was 10 and the length was 13, because we know that the length has to be 3 more than the width. So I could say, okay, 10 times 13 does not give me a number bigger than 300 for my area, because we know that the area needs to be from 300 to 700. So let me try other numbers. Let me try, maybe we can call the length 15. Oop. So then that means that the 270, nope. Let's try 16 for the width, so that means that the length would have to be 19. Oh, there we go. That's our first one that's worked so far. So let me grab my eraser. I know that if my width is 16, my length is 3 more, so that would be 19. And that would make my area 304. I bet 17, and then we'd have to have 20 would work too. 18 and 21, 19 and 22, and 20 and 23. But let's check all these. So all I was looking for was one that would work, and then I can kind of guess and check the rest of them from that one that I found. Because I know that my area needs to be from 300 to 700, and that my length needs to be 3 more than my width. So 17 times 20 is 340. 18 times 21 is 378. 22 times 19 is 418. And 20 times 23 is 460. And those will all work. This last one just says to graph the inequality. So let's go ahead and do that. So we're going to have y is greater than or equal to negative 4x squared. And then we're going to have minus 3x plus 7. So let's grab some key features from here. The vertex, let's see if I can grab some other ones. Okay, So this one is going to be 0, 7. Let's look at this vertex. It's a little bit past 0 and about 7.5, so maybe there. And x-intercept would be 1. And negative 1.75, so almost 2. And that should give me enough to where I can kind of sketch a graph. And it is a solid line. And then we are going to shade everything on the outside. And we're done. Now for this inequality, I'm actually going to do the same thing, and I'm going to graph it. But remember, since we're only dealing with one variable here, just x, not x and y, I kind of think I want to do something a little bit different and make myself a number line. And let me fill in those numbers once I kind of get an idea of what my graph looks like. So let's do x squared minus 11x plus 21 is greater than or equal to 3. Okay. So it looks like we're looking at 2 and 9. So let me go from 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And these are going to be closed circles because it's an or equal to. So I'm going to put a closed circle, I think, at 2. I'm going to go this way, and then we're going to put a closed circle at 9 and go this way. I kind of just like looking at it as the number line a little bit better because sometimes with all of that extra shaded area, it just looks kind of confusing. So basically from this, I know that this is an or. We know that our x value is either going to be less than or equal to 2, or x is going to be greater than or equal to 9. But there's no number in the world that is going to be less than 2 and bigger than 9. So that would be our final answer. Let me make sure I type this in correctly. Oh, I put 3, not negative 3. My bad, you guys. So it's actually just 3 and 8. So we just gotta switch that up a little bit. So I just changed this to 3 and 8. All I did there is I just forgot the negative. So make sure that you're double checking because I did not and I messed up. So don't do what I did. Thanks, you guys.